Now, today discuss about the next another topic in semiconductors is direct and indirect band gap of semiconductors. Is direct and indirect band gap of semiconductors. First, discuss the direct band gap of semiconductors. Direct band gap semiconductors. Here, draw the diagram of direct band gap of semiconductors. Direct band gap semiconductors. Direct band gap semiconductors. This is the diagram for direct band gap semiconductors. This is the valence band. This is the conduction band. Between this gap is energy gap. This direction is energy gap, energy direction. This is the wave vector direction. First point. In direct gap semiconductor, the band diagram in direct band gap semiconductors the band diagram between energy and wave vector that is k, that is E minus k. Next point, in In this semiconductors, the maximum of the valence band, the maximum of electrons in of the valence band and minimum of the conduction band. The maximum of the electron in valence band, the minimum of the electron in the conduction band. At the K values are same in both the bands. Valency band electrons is maximum, conduction band electrons is minimum, but K vector, wave vector K is same. Next, in this semiconductors, when electrons recombine with hole, emits their energy in terms of light. In this semiconductor, when the electron recombine with the holes and emits the energy is light waves. Next, the lifetime. This semiconductor lifetime, that means recombination time. That is the lifetime of charge carriers. Is very less. Here the compound semiconductors, here the compound elements are gallium arsenide, indium phosphorus. These are the examples of direct band gap semiconductors. The band gap of indium phosphorus is 1.5 0.35 electron volts, and gallium arsenic band gap is 1.4 electron volts. The band gap, the direct band gap semiconductors are used to fabrication or fabricated for LEDs, that is light emitting diodes, and laser diodes. Laser diodes. Once again, I tell you here, today concept is direct and indirect band gap of semiconductors. First of all, we are discussing about the direct band gap of semiconductor. Draw the diagram of direct band gap semiconductors. This is the valency band, this is the conduction band. Take this direction is wave vector. K is wave vector. Wave vector. Okay, take the wave vector, and this direction is energy. Now, first point is, in the direct band gap of semiconductor, the band diagram between the energy and wave vector K as shown in the figure. In this semiconductor, the maximum of valency band in the semiconductor, the maximum of electrons stay in the valency band and minimum of the electrons stay in the conduction band. But wave vector is both the bands are same. Next point is, in this semiconductor, when an electron recombined with hole, suppose when the electron is excited into the conduction band from the valency band to the conduction band, after that the electron is downward follow into the valency band and recombine with the hole. This process is continued to emit the photons, that is the light waves. Next, in this semiconductor, lifetime of the charge carriers is very less. Suppose electron is excited into the conduction band and de-excited into the valency band. This lifetime is very small, that is very less. Here the compound elements are the examples of direct band gap semiconductors. To take the elements is gallium, arsenic, indium, phosphorus. These are the examples of direct band gap of semiconductors. Here indium phosphorus band gap is 1.35 electron volts and gallium arsenic band gap is 1.44 electron volts. The direct band gap of semiconductors are used to fabricate for, that is making of LEDs, that is LEDs mean light emitting diodes, and used for laser diodes. The direct band gap of semiconductors are used into the fabrications of LEDs and laser diodes. Next, another band gap of semiconductor is indirect. Indirect band gap of semiconductors. Draw the diagram of indirect band gap semiconductors. This is energy. This one is K vector, that is wave vector. This one is the valence band. This gap is energy gap. This one is conduction band. Conduction band. This figure is indirect band gap semiconductor. Indirect band gap semiconductors. Indirect band gap semiconductor. This diagram is represented the indirect band gap semiconductor. This is the valence band. This one is the conduction band. Take the graph between the wave vector and energy. This gap is energy gap or forbidden energy gap. First point, in indirect band gap, indirect band gap semiconductors. Indirect band gap of semiconductors. Diagram is drawn. Diagram is drawn between energy and wave vector, that is EK curve is shown in figure. The indirect band gap semiconductor diagram is shown between the energy and wave vector is shown in this figure. Here in this semiconductors, the maximum of the in these semiconductors, the maximum of the electrons of the valency electron valency band and minimum of the electrons in conduction band. But wave vector k is different values of both bands. This means in this semiconductor, the maximum of the valency band of the electron and minimum of the electrons in the conduction band. But k vector is different for different bands. Next, in these semiconductors, when an electron recombines with the hole, emits their energy in terms of heat, energy, that is heat. So indirect band gap semiconductors are not used in the preparation of semiconductor laser. The preparation of semiconductor lasers. The lifetime, the band gap semiconductors lifetime means recombination time. Lifetime means recombination time. It is the charge carriers. Is more. Lifetime is more. Next point is the elemental semiconductors. Elemental semiconductors. That is like germanium and silicon. Are example of example for indirect gap semiconductors. Indirect band gap semiconductor. Here germanium band gap is germanium band gap is 0.7 electron volts, and silicon band gap is 1.12 electron volts. This band gap semiconductors are used to fabricate diodes and transistors. Now this one is the indirect band gap of semiconductor. First of all, draw the diagram of indirect band gap of semiconductors. Here this one is the valency band, here this one is the conduction band. This direction is the energy, this direction is wave vector k. Between the two bands gap is energy gap. In this indirect band gap of semiconductor, diagram is drawn between the energy and wave vector, that is E minus k wave curve is shown in this figure. In this semiconductor, the maximum values of electron in the valence band and minimum values of electron in the conduction band. But wave vector k is different for different bands. Wave vector k is different for different bands. In this valence band, wave vector is different. In this conduction band, wave vector is different. Next, in these semiconductors, when an electron recombined with holes emits their energy in terms of heat. Suppose in the valency band some electrons is there, this electrons is excited to the conduction band and another re-excited to into the valency band, that is the to recombine with holes. In this process, some energy is released, that energy is heat energy. In the indirect band gap semiconductor, releasing of energy is heat energy. In direct band gap semiconductor, releasing of energy is light energy. Don't confuse that direct band and indirect band gap of semiconductors. Next, indirect band gap of semiconductors are not used in the preparation of semiconductors laser. By using this energy band gap of semiconductor does not preparation for the semiconductors lasers. Here this lifetime of charge carriers is more, that is the recombination of time. When the electrons is excited from the valence band to the conduction band and re-excited to the conduction band to valence band, some time is taken, some more time is taken, that is lifetime also more. Next one is elemental semiconductors. These are germanium, silicon are the examples for indirect band gap semiconductors. The examples for indirect band gap of semiconductors, that is the germanium and silicon. Here germanium band gap is 0.7 electron volts and silicon band gap is 1.12 electron volts. This type of band gap semiconductors are used to fabricate diodes and transistors.